Good day, everyone! In today's lesson, we're going to tackle about polar and non-polar. Now, let's get into it!
At the end of the video, you will be able to determine whether a molecule is polar or non-polar based on its electronegativity. So let's dig more. Now, think about the magnet. Magnet have both a positive pole and a negative pole. So does batteries. So does the earth. When things are different at each end, we call them polar. Some molecules have positive and negative ends too, and when they do, we call them polar. If they don't, we call them non-polar. Things are polar can attract and repel each other. Opposite charges attract, alike charges repel. The two magnets in the video will attract because their opposite poles are near. Reverse one of them and they will repel each other.
To further understand what is like repel like, this cooking oil and water will let you understand what it's all about. Now, this cooking oil, I will put this into my hand. Observe what happened when I rub it in my hand. Now I will wash it with the raw water. Ew, that's gross. And observe what happened. The big question is, does cooking oil and water repel itself?
I know that you are really familiar with this, so be ready class because we're going to use a periodic table of elements to determine the electronegativity of unspecific elements. So what is electronegativity? Electronegativity is a measure of a tendency of an atom to attract a bonding pair of electrons. As you can see, there are electronegativity value in the specific elements. The following skill will let you understand how to use this value. Electronegativity trend illustrate the direction of electron based on the position of the element on the periodic table. The electronegativities of elements tend to increase from left to right across a period and also increase from top to bottom of a group. So there are types of chemical bonds. We have covalent bond and ionic bond. So what are these? The table flashed on the screen is a Pauling scale. It indicates the types of bonds that vary from value of electronegativity difference. You can say that the bond is ionic when the value difference is 1.7 or more electronegative, and polar covalent when less than 1.7, and of course, you can say that it is non-polar covalent when it ranges with 0 to 0.4 electronegative. But let's focus on polar covalent and non-polar covalent bond. So what really mean when we say polar or non-polar? So I will tell you a story of a polar bond. Hydrogen and nitrogen are both love candies. One day they decided to buy a candy in the store. After they bought the candy, they tasted, and nitrogen was so disappointed of what he got. And nitrogen is very happy because he picked a very delicious candy in the store. And nitrogen said, "Can I taste yours?" Suddenly, he grabbed it and ate it. Hydrogen was sad and nitrogen is very happy for what he did. He said he was satisfied. Poor hydrogen. And that is a story of a polar molecule. Nitrogen is the most greedy, has a power to do it. He didn't think of other just to satisfy itself. Polar molecules are those molecules that has higher electronegativity. They have a power and ability to pull others' electron in order to gain stability. And what about non-polar? I have also a story for that. Oxygen 1 and oxygen 2 is a twin sister. They decided to hang out and go shopping, and they walked through a jewelry store and get in love with the only pair of earring in the store. It was a pearl! They both screamed with excitement. Can I buy it myself? Said Oxygen 1. Yes, you could, Oxygen 2 added. Since you're my sister, I will let you buy it, but please, share it with me. Of course we could, Oxygen 1 said. And they both happily leave the store. So non-polar molecules are very generous to each other. They are capable of sharing their electron to other elements to gain stability. So now, how to determine whether a molecule is really polar or non-polar based on its electronegativity value? We have here an example, the nitrogen and hydrogen. Nitrogen has 3.0 charge and hydrogen has 2.1 charge. So all we have to do is to subtract the smaller electronegativity from larger one to find the difference. Example, hydrogen has 2.1 and nitrogen has 3.0. It is equals to 0.9. And when we look at the Pauling scale table, it turns out to be polar. So let's have now an example of a nonpolar bond. We have oxygen 1 and oxygen 2. It has a charge of 3.5. So if this is 2 is being subtracted, it turns out to be 0. So let's go back to the table and it's said to be nonpolar. Very easy, right? Always remember, class, that elements with a high electron negativity have a strong pull on electrons, while elements with a low electron negativity have a weak pull on electron.
That's it for today, class. See you on our next lesson. Bye-bye.